Now I'm sure this thumbnail, despite looking pretty cool, has probably raised some questions. Like, how noticeable could the effect of any natural increase in testosterone really be? Well, as you're about to see in this video, the answer is extremely noticeable. Changes within the natural range, including drops that lead to low levels, and increases that cause naturally elevated testosterone, can have several major effects, both mentally and physically. And although I have used the methods we're going to cover to successfully increase my own levels, you won't be expected to just take my word for it. Every beneficial effect included in this video will be cited and backed by research. This also includes the methods we're going to investigate to boost our testosterone levels later on. Valuable research on the effects of health, lifestyle, and social mechanisms, as well as dietary studies and a look through clinical trials on the best testosterone booster supplements, will all contribute to our testosterone maxing plan. Before we can see how to raise levels and the effects this has, first we need to answer the question of what is testosterone and what does it do? Have you ever wondered why testosterone, given its importance in the male body, has a natural range that varies so widely? I mean, take two men, and let's say one day they both take an at-home testosterone test. It comes in the mail, they both provide their samples and send them off to be analyzed.
Quick side note, while I get more into the specifics of testing levels later, I know since I mentioned it now, I'll still get a bunch of questions. So don't worry, we're going to cover it coming up in full detail, and the specific testing service I use is even going to be linked below.
2 weeks later, they log in and see their results. Frank's results come back at 304, while Dave's come back at 915. They're both within the normal range, and yet one man's levels are 3 times higher. Compare that with the blood range of something else, say sodium for example, where the difference between the top and bottom of the normal range is just 9%. So if our body is capable of regulating sodium so closely, why does it let levels of a key signaling hormone like testosterone fluctuate so randomly? The answer, as you might be able to guess, is exactly that. It's a signaling hormone, and these varying levels aren't random at all. Now, to explain this properly, we need to start this video off a little differently. Instead of just kicking it off with a bunch of studies that link improved testosterone levels in men with everything from increasing muscle mass, improving their mood and motivation, and even in some studies earning more money, none of this will actually help you if we don't also discuss how you might personally be able to increase your testosterone levels and actually see these positive changes for yourself. Now, if we're going to do it this way, it's going to require taking a bit of a step back in how we understand testosterone. So by the end of this first section, you'll understand why testosterone levels can control so much. For it to really make sense though, we're going to need to start at the beginning and see what life was like before testosterone. I guess it means I have to say it now. It all started in the Proterozoic era, specifically at the end of it, 500 million years ago. Over the billions of years leading up to this moment, life had evolved to pretty much resemble a swimming pool during a chlorine shortage. Then, seemingly out of nowhere, the fossil record shows there was a sudden explosion in life. Arthropods, the ancestors of today's insects and crustaceans, and chordates, which are creatures with rudimentary spinal cords that later became mammals, birds, and fish, all trace their lineage back to this one moment. Researchers sequencing ancient DNA from this time period recently discovered a mutation that occurred just before this, which may be responsible. This mutation altered the binding affinity of the estrogen receptor, which until that point was the only hormone of its type. With this mutation, new receptors could now suddenly detect 2 additional hormones, cortisol and testosterone. When hormone receptors in cells are triggered, they activate DNA that causes specific changes to the cell. Having multiple hormones to work with meant these organisms could now be far more adaptable than they were before. And because different kinds of cells will react to the same hormone in different ways, by releasing one hormone, an organism could adjust all its bodily functions at once. The physical and behavioral changes that get packaged together are usually all related to optimizing for success in a specific scenario, including, for example, a scenario that requires an individual to compete for resources and access to females. Then, The brain simply watches for indicators of that situation and responds by releasing hormones. Instant adaptation. Multiple hormones also meant that now creatures in the same species could be subdivided into male and female versions. Heightened testosterone levels during development are responsible for the differentiation of the male body. And throughout life, elevated testosterone levels in males continue to be responsible for maintaining much of their physical and behavioral differences. Because of this general function, many of the effects of circulating testosterone remain fairly consistent across all mammals, from physical effects like reducing fat and increasing muscle mass, to behavioral changes that increase competitive traits and the drive to reproduce. What you might not have known, though, is the testosterone levels between two males of nearly any species will usually vary considerably. It's not just in humans. I think the confusion about varying levels is often underpinned by a belief that all males should have the same testosterone levels, so therefore, something must be wrong if they don't. But research shows this assumption has one major oversight. See, due to genetic and behavioral differences between them, in any given environment, some individuals will simply perform much better than others. Multiple cues that indicate high performance are then detectable by the brain, from obvious ones like health status to more surprising ones, including the ability of some animals to comprehend their social rank, access to resources, and territorial claims. Because genetic differences often underlie these differences in performance, the odds of reproductive success, where their offspring survive into adulthood, also wouldn't be equal for every male. It wasn't long before the brain's testosterone-releasing mechanisms evolved to take this information into account, learning to release the greatest amounts in individuals where reproduction was most likely to be successful, while reducing levels in those where survival of the offspring seemed less likely. This system works even better if the females are in on it too. So in many species, higher levels of testosterone in these high-performing individuals triggers the development of obvious physical traits, which females can easily pick out and are drawn to. Not only does this system benefit the species as a whole, but it even has advantages for the lower performing males. Lower testosterone levels increase fear of danger, threat avoidance, and fat storage, all things that would actually be useful to a male who's already struggling to survive. So rather than acting like an on-off switch, think of the variation in levels like a slider, with small adjustments constantly working to fine-tune testosterone levels and keep reproductive drive highest in individuals whose brains see indicators of high performance. This research into social endocrinology explains why one man can have levels 4 times higher than another, and while medically their levels would both be considered natural, the differences in how they think, feel, and even look might be as different as night and day. For a long time, medical science held, let's call it, a much simpler view of testosterone. We'll pick it up in 1889, when physiologist Charles Edward Brown-Séquard decided it would probably be a good idea to extract liquid from the testes of guinea pigs and administer it directly into his bloodstream. To everyone's surprise, the 70-year-old researcher began reporting increased strength and improved mental function. In 1935, Ernest Lecoeur finally managed to isolate this mystery hormone, which he named after its source, testosterone. Up till now, doctors had been noticing a strange pattern of symptoms in many of their male patients. Men all complaining of low energy, depression, and loss of libido. Some of the earliest studies on testosterone were done on these men, where they discovered replacing testosterone in them would almost immediately resolve these symptoms. Through the 50s and 60s, the research focus shifted to its potential medical applications as a muscle-building agent, possibly because it was the effect that was the most easily observed. It's only been recently that researchers figured out how mammals' brains can read species-specific performance cues and then respond with testosterone as part of a larger system to modify a range of physical and mental traits, all intended to either increase or decrease their social rank and mating success. To me, this opens up an intriguing possibility. If we can see the mechanisms that control it in humans and develop a plan to maximize our levels, the benefits could go far beyond just muscle. Imagine tapping into a whole set of traits geared to help us, as the research puts it, increase our social status, resources, and physical attractiveness. Okay, enough imagining. Let's now check the research and see exactly what effects have been proven in humans, starting with the mental ones. If testosterone levels are low enough to create medical problems, it's called hypogonadism. The exact level this starts at, though, depends which medical organization you ask. As a general rule, though, total blood levels will usually need to fall below 350 nanograms per deciliter before you'd notice negative symptoms. And if you're thinking there's no way this would ever apply to you, I've seen studies where the proportion of men below 350 is as high as 4 in 10. Some negative symptoms associated with low testosterone are obvious, like decreased libido, male factor infertility, and ED. But there's also a much broader range of troubling effects, which include depression, anxiety, difficulty sleeping, increased irritability, fatigue, and cognitive impairment. In one study, which compared mood and cognitive test scores between men with average levels of testosterone against those with low levels, while mood scores in several areas dropped considerably in the low T men, the greatest discrepancy was actually in their cognitive scores, with the low T men demonstrating far worse concentration, slower psychomotor performances, and lower levels of executive functioning. Remember, research in mammals shows that testosterone's broad range of effects exists to regulate competitive and status-seeking effort. It does this because with this higher rank comes access to limited resources as well as increased mating opportunities. But the specific traits modified to achieve this are species-dependent. For example, elevated testosterone increases competitive behavior in sheep through a sudden desire to headbutt their enemies. In humans, with our far more complex social structures, enhancing competitiveness is achieved through a far more delicate set of traits. This is why rising testosterone levels in humans have been shown to promote both persistence and competitive motivation while reducing stress and fear. Testosterone is also understood to contribute to the likelihood of future success. And sure enough, in humans, we see studies showing increased energy levels, as well as enhanced memory, learning, and cognitive ability. So does this mean having high testosterone will make you successful? Well, in some studies there is a relation. In a study that followed a group of financial traders, researchers wanted to see if they would perform better on the days where their morning testosterone tested above average. On days where they came into work with higher levels, they actually ended up earning 3 times more profit than their daily average. Experienced traders did even better on their high testosterone days. Men that had worked there for over 2 years saw profits more than 4 times higher than normal on their high testosterone days. But despite this, studies that bring subjects in to compete in a lab setting usually don't find a major association between their testosterone level and performance, which really shouldn't be that surprising. Because remember, while obviously higher testosterone will increase competitiveness and motivation to win, a major confounding factor will always be your individual skill set. If someone who is terrible at financial math walked onto the trading floor off the street having very high testosterone wouldn't magically make them a better trader than the guys who've been doing it for years. Remember, it was the most experienced traders who responded to higher testosterone with the best results. One final thing before we move on to physical effects is that it might have seemed odd that irritability was actually heightened in low testosterone men. You'd think aggression would be instead increasing with high levels. This was investigated by researchers in a recent study where half the participants were administered testosterone to artificially raise their levels. They had the subjects participate in a game that required 2 players to split a sum of money. Depending how the subjects felt about the offer they were given, they had the option to either reward or punish the other player. They found the testosterone group dished out significantly harsher punishments in response to small offers which they perceived as unfair. And yet, they also behaved more generously with their rewards. When they felt an offer they were given was fair, they they tended to actually gift more money to the other player. So rather than increasing general aggression indiscriminately, it appears added aggression is mostly saved for situations that mimic social threats and dominance challenges. Because human interactions are complex, status may be equally obtained by non-aggressive, even pro-social means, such as generosity, explaining why research shows testosterone increases multiple pro-social behaviors, including cooperation, fairness, and reciprocity. When you really step back and look at these qualities, they don't sound like the personality traits of some overly dominant bully. Instead, these sound like the personality traits of a good leader. I have to say, looking at this wide range of mental benefits, trying to optimize levels really does start to seem like a smart idea. Let's first, though, quickly run through the physical effects testosterone has on bone, muscle, and fat. Now, a common myth in the fitness community is that testosterone changes within the natural range won't affect body composition. This myth stems from the fact that the majority of medical research into testosterone is conducted on the extremes. So while studies into these hypogonadal men reliably show low testosterone results in muscle loss and fat gain, and studies where added doses push levels far above the natural range show the opposite, when it came to the middle, for a long time we simply didn't have the data. Identifying this blind spot, researchers devised an experiment to move men's levels within the natural range, and then compare before and after for changes to body fat and muscle. 198 men entered the study and had baseline measures taken. Then they were given a GnRH analog, a type of drug that stops natural testosterone production. They divided them into groups and assigned each group its own testosterone replacement dosage. This meant average levels in each group would shift to a new spot in the natural range. From just 44 nanograms per deciliter, which is severely deficient, all the way up to the highest group, which averaged 805. They were kept at these new levels for the duration of the 16-week study, after which the men were retested to see if their body composition changed in response to their new level. Before the study, the group that got the highest dosage had levels that averaged 529 nanograms per deciliter. So, going up to 805 meant an increase of about 275 nanograms per deciliter. If testosterone's ability to control body composition is part of its adjustable status-enhancing role we talked about, for example, maybe to help you overcome physical threats or signal rank like how other animals do, even at a change of this size, you'd think we could expect to see some sort of body recomposition response. And checking the results, that's exactly what we see. Even after just 16 weeks at their new level, there was already evidence of a body recomposition. Average lean mass had increased by 2%, while average body fat was down 3%. The more concerning part is what happened to the other men. Since going into it, they all had average levels around 500 nanograms per deciliter. These 16 weeks actually represented a decrease for them. Here we see the opposite trend. Fat mass increased, with the lowest testosterone levels correlating with the most fat gain, while lean mass, which includes muscle, also dropped significantly in the two lowest level groups. So it turns out that changes even within natural levels really can noticeably change your body. The challenge with interventional studies like this is they can't risk doing any long-term harm. Since low testosterone levels are shown to result in harmful bone loss over time, the study couldn't go beyond 16 weeks. So although the researchers acknowledged the effects of testosterone on muscle and fat are shown to be time-dependent, we can't ever know just how far these changes would have gone if the study had continued. And now that we've seen its effects are pretty much a genetic formula for competitive drive, motivation, and even now physical health, whether you want to be like me and actively take steps to naturally increase your levels, or you simply want to understand the factors that control levels to avoid inadvertently doing things that could lower them, in this next half, we're going to go through everything to do with how these levels are controlled. But first, we need to quickly review how testosterone is released and measured. When we hear studies refer to testosterone levels, they are referring to how much is circulating in the blood. The most common unit of measurement tells you how many nanograms of testosterone are in 1 deciliter of blood. Sometimes called the total value, this measure provides a solid idea of how much testosterone your body has to work with levels below 350 marking the start of what's considered low. There are a few more measures you may hear about because testosterone can actually circulate the blood in 3 different ways. About 60% circulates the blood tightly bound to a specific glycoprotein called SHBG. Another 38% is weakly bound to albumin, and the remaining 2% of testosterone is what's free at any given moment. Being free from these binding proteins allows it to be the most active, easily passing into cells where it can then activate the androgen receptors inside. You'll sometimes hear that only the 2% of testosterone that's free does anything, but up-to-date papers are quick to point out that because the bond is quite weak, the additional 38% bound to albumin turns out to be biologically active also, able to break away and trigger effects. Recent evidence also suggests that there are unique cell surface receptors that are specifically triggered by the SHBG-bound testosterone. So although when I check my testosterone, I do also opt to check SHBG levels, since I'd want to know if it started getting too high and interfering with free levels, and while measures of free testosterone definitely have their place in diagnosing more complex conditions, total testosterone levels are really what I use to track my long-term improvements. And considering they are also what's measured in most of the research, that's where I'm going to focus the most. Instead of constantly going to the clinic to get these regular tests, I use a service that will mail me the test, which I can then just send back for my results. It's actually pretty affordable. Their total testosterone test is less than $100. If you want to know where your levels are or start tracking them more regularly like I do, I linked it below if you're interested.
And I actually managed to get a sponsored affiliate link from them. So if you take the test, it supports the channel too.
Something really important to remember when you check your levels though, is that testosterone release follows a daily rhythm, with a noticeable spike occurring each morning. Based on research recommendations, this is the time when you want to take your measurement, since the difference between men with low and high levels is usually the most pronounced here. As far as where it comes from, the majority of testosterone in the bloodstream is produced by specialized cells in the testes called Leydig cells. It forms when cholesterol within the cell is pulled into their mitochondria. Once inside, an enzyme turns it into pregnenolone, which exits to another part of the cell where it's converted into testosterone. How quickly cholesterol gets converted is controlled by luteinizing hormone, a hormone that binds with receptors in the Leydig cells. More luteinizing hormone means more testosterone production. Luteinizing hormone originates far off in the brain, specifically in a pea-sized gland called the pituitary gland. In men with low testosterone, the specialist will sometimes want to MRI this region to look for abnormalities. The release of this luteinizing hormone from the pituitary is itself controlled by receptors which, as you might have guessed, are triggered by yet another hormone called gonadotrophin-releasing hormone, which itself is released from neurons located in the nearby hypothalamus, which is the H in the HPG axis. What you barely hear talked about, though, is what areas of the brain can activate this chain. It turns out, a lot of them. I found a great academic review that outlines how senses of sight, sound, touch, and smell, as well as multiple brain areas involved in processing health and social information, have all been shown to not only activate the HPG axis, but also they can adjust receptor sensitivity at every level of it. This explains why so many different factors can affect testosterone. In some animals, it's seasonal cues that trigger group-wide level changes for their mating season. In others, it's their individual social status and health signals. It's also important to distinguish between a momentary spike and a long-term adjustment. Sudden temporary spikes occur in response to specific situations, since brain regions are able to recognize these events and trigger the HPG axis to release a burst. These are intended to cause just a temporary behavior change. For example, to influence the choice to respond to a sudden challenge by competing or backing down. With each spike, the brain watches to see how the situation plays out, and if the added testosterone leads to a favorable outcome, like say you do decide to compete and end up winning, it can upregulate the entire system. Over time, this can lead to long-term adjustments in the axis, shifting your baseline testosterone levels up or down, giving rise to the emergence of a distinct behavioral profile. For example, a dominant or submissive personality. While the temporary spikes tend to be studied more, as we jump now into the ways we can maximize our own levels, it's evidence for long-term changes that I'm going to mostly focus on. First is research on dietary deficiencies and testosterone-boosting supplements. This seems like the best place to start because these would be the easiest to change, while still being capable of having a big impact. There's considerable evidence to suggest deficiencies in vitamin D, zinc, and magnesium can all lower testosterone. Vitamin D, in its active form, isn't technically a vitamin. It's a hormone, synthesized within our body from inactive vitamin D, which we get through diet and sun exposure. It binds with vitamin D receptors, including ones located in the Leydig cells that make testosterone. In 2 separate studies, just correcting deficient vitamin D raised testosterone levels by 18 and 30%. Important when you consider European medical stats that suggest that 12.5% of the entire population have vitamin D levels in the range that was supplemented in these studies. Associations between even mild zinc deficiencies and low testosterone inspired researchers to see if zinc deficiency was playing a causal role. They measured testosterone in a group of 40 healthy men and then eliminated zinc from their diet for 20 weeks. When they remeasured, testosterone was down significantly. They also found a group of men who were already zinc deficient and put them on supplemental zinc, and testosterone improved from 239 to 409 nanograms per deciliter. Using a linear regression model, researchers also found magnesium showed a strong and independent positive correlation with testosterone, even after adjusting for age. However, the studies that have shown magnesium raise testosterone levels, unlike the other 2, involve its use in combination with physical activity, presumably because intense activity can drop magnesium levels. So to protect your testosterone levels, always ensure you're getting an adequate intake of these vitamins and minerals. The testosterone booster supplement I personally take already has all 3 in it, so I kind of see that as my insurance. The main reason I picked it though was for its other ingredients that show evidence that they can actually increase levels. I'm actually thinking about doing a complete video just on testosterone boosting supplements, so I'm only going to run through a few quickly here. One of the ingredients you may have guessed I'd mention is ashwagandha. I actually have an entire video on it where I reference several studies. In one, 2 groups of young men worked out for 8 weeks, and the only difference between the groups was one received 600 milligrams of ashwagandha extract. By the end, the men who got the ashwagandha had testosterone levels up from an average of 630 to 726, whereas the group that didn't get it didn't significantly change. This is slightly less than the increase shown in a 90-day study on men with fertility problems that saw testosterone increase by 17%. Another one we've talked about a really long time ago is fenugreek. I take a specific standardized extract of it, which during a clinical study in men over 40 showed a small but significant 12% increase in serum levels of testosterone. Now, this one's more tricky because similar studies in younger men don't always show the same effect. Despite that though, both studies in young and old men do show a significant increase in libido, presumably through other mechanisms. There are actually 2 more supplements I want to mention from the list I take, but I think they will actually fit best in the upcoming sections. Since you guys usually comment and DM asking me what I use personally, I link the specific blend I take in the description. It has all the ingredients I'm going to mention and in doses similar to what's actually used in these studies. Since there's some crossover between this and the adaptogen blend I mentioned taking in another video, I'll say I tend to take this the majority of the time, especially before dates for reasons you'll understand if you try it. But if life starts getting overly stressful, I switch over to the adaptogen blend instead. So we've talked about how testosterone levels can affect your personality, making you more confident, driven, energetic, and social. Something as innocuous as a mineral deficiency, essentially being able to change your personality, dropping motivation and reducing confidence, is something that really makes sense to be taken seriously. But remember, while these levels do enhance traits designed to help you climb social ladders, ultimately, they do also adjust over time to reflect your current standing. In primates, social cues that signal rank, while complex, play a large role in regulating the HPG axis, causing both short and long-term changes in testosterone. In a study on a group of recently introduced monkeys, they immediately began fighting for rank, and when the dust settled, the winner's testosterone levels were elevated 10 times higher than baseline, while the loser's levels dropped to just 10% of where they were. A study that tracked a group of baboons found that higher levels of testosterone significantly predicted the males who would go on to achieve a high rank and access to females. Aggression, being used as a primary tool to climb rank in primates, where hierarchies depend on physical dominance, caused a lot of confusion when researchers tried to adapt these findings to look for long-term changes in humans. The problem, though, is that within human societies, climbing rank in a hierarchy is rarely just about physical dominance. So in conclusion, I think if given this new role, I can share some valuable information to advance the entire company.
You make a very compelling pitch, Mr. Wilson. Now you, Mr. Bananas. It's your turn. Show me why advancing you instead is the right choice to bring prosperity to our company. Mr.
As humans rely far more on intelligence for survival, we've evolved to favor leaders we can learn and seek advice from, versus those that rely just solely on threats and intimidation. This led researchers to a new form of status, separate from dominance, called prestige, which finally explains why the traits we see testosterone increasing in humans are geared towards strengthening our social relationships. For example, studies have shown that while winning a competition triggers a temporary testosterone increase, winning in front of a supportive audience significantly increases the size of that spike. In elite hockey players, even just watching back a game where their team won causes a temporary 40% spike in testosterone. In 2018, a study was published to look for long-term changes in men's testosterone in response to newly acquired prestige. It followed a group of 220 individuals. They were all members of their university marching band. Since it was an elite band, the time commitment often exceeded 20 hours per week. 4 weeks into the new term, they tested everyone's testosterone levels. As well, they surveyed everyone and asked them based on initial impressions to nominate the individuals they looked up to on the basis of their talent, as well as nominate individuals they would be likely to go to for advice. 2 months later, they remeasured everyone's levels. Their prediction was that, like with the monkeys who won dominance fights, earning prestige early on would lead to increased testosterone over time, reflecting their high social rank. And after checking the results, they found a strong correlation between prestige and changes in testosterone level. If a man received 10 nominations, it was enough to put him in the 90th percentile. These men had testosterone levels up by over 20%. Meanwhile, what's more concerning to me, the men who were deemed low prestige didn't just remain the same, their levels actually dropped. After running the data, the model predicted going from the bottom 25th percentile to the 90th percentile would result in an average difference of about 80 nanograms per deciliter. So what lessons can we take from this to apply to ourselves? First off, just knowing that earning prestige can result in the benefits of higher testosterone should in itself be added motivation for you. Use this as fuel to push yourself to gain respect in your own field and focus on becoming the type of person who would have earned more nominations. This research even inspired me to personally increase my own exposure to signals of prestige. So if you check the description below, I've put a link where you can enter a question. Once per week, I'll pick someone randomly for a free 20-minute video call to see if I can help answer it. This is also why I check my testosterone levels regularly, to watch for these kind of shifts in response to life's changes. Finally, I also think realizing that low prestige men had their levels fall, which itself can have negative effects, should really be a wake-up call. If you're being treated badly and gaining prestige doesn't really seem possible in your current situation, maybe it's time to consider the positive benefits to leaving that toxic environment. While I haven't actually seen a study like this in humans, in monkeys, even just leaving the group where they were a lower rank increased their levels somewhat. Okay, next is research into the effects of health. Something we talked about earlier is how testosterone diverts more energy towards processes designed to influence competitive success, like muscle mass, and away from processes designed to maximize long-term survival, like fat storage. Another area this extends to is the immune system, where naturally elevated testosterone actually downregulates certain energy-intensive immune processes, reprioritizing that energy. The consequence of this is that testosterone needs to be sensitive to markers of health and be ready to drop if the individual becomes sick. In nature, only individuals who are very healthy can support high levels. Countless human studies show dramatic drops in testosterone in response to serious illness and injury. It makes sense. When an individual's immune system is challenged, energy needs to be refocused back on immune function. This is partially controlled by the HPA stress axis, which responds to illness with stress hormones that suppress testosterone. Now, what about the association with age? The idea that testosterone will always decline with age at a steady and unavoidable rate is really being questioned. The first clue that there was more going on was in multiple studies that have shown older men who remain in good health don't experience a drop in levels. This prompted a recent study that tracked the levels in over 1,500 men for 5 years. They also tracked multiple health markers besides just age. They performed a multivariate regression analysis, which simply means they used computer modeling to look for the most consistent factors in the men whose testosterone fell over the 5 years. Across everyone, the decline in levels averaged out to a drop of about 0.8% per year. But when they took a look at the men who remained free of any chronic health conditions, like obesity or hypertension, the steady decline in levels disappeared below statistical significance. They found the strongest predictor of a decline wasn't increased age, it was increased weight. A separate meta-analysis of 13 studies that measured testosterone in men of all ages revealed the true variation over the male lifespan. While average levels do indeed peak at 18 and fall slightly until the age of 40, beyond that, the average across men of different age brackets remains fairly steady. While the variance does increase a bit with age, levels are surprisingly variable at all ages, with low levels clearly affecting not just older men, but young men too. Just by age 27, 30% of men are already below that 350 threshold. Meanwhile, at more than twice their age, 10% of 60-year-old men still have levels above 650. If you want to see something with a more clear association, look instead at these studies on obesity. One meta-analysis found when obese individuals lost just 9% of their body weight, testosterone increased by on average 84 nanograms per deciliter. And after surgical weight losses, which averaged 32% weight reduction, those increased levels by a staggering average of 251 nanograms per deciliter. While I personally use fasting to keep my body fat low, something that impressed me about the testosterone booster I settled on is that it contains EGCG, a molecule extracted from green tea that, in its own meta-analysis, was shown to increase daily fat burn by up to 16%. Considering that reducing body fat may have the single biggest effect on testosterone that we've seen so far, I see including it as fitting well into the big picture of raising levels. Let's round this off with a few final lifestyle factors that research has shown can also affect levels. One social factor we haven't covered yet is a distinct shift in testosterone and behavior that's shown to occur when men become fathers. Considering that fathers perform parental duties in just 5% of mammals, it's no surprise a system exists in humans to divert male behavior away from what's associated with high testosterone. Evolutionary researchers believe this change exists to refocus the father's attention to childcare and nurturing. In a study that followed men for 4.5 years, those who became fathers saw their testosterone levels fall by 27%, an average drop of 170 nanograms per deciliter. Based on the evidence, though, there's one factor that can significantly reduce this drop, and that would be how often they engaged in reproductive activity. Just a note, I'm using the term reproductive activity so YouTube doesn't flag this video. But every time I say it, you can just take it to mean this. Anyway, back in the study, they also surveyed the fathers to see how many times per week they engaged in this reproductive activity. They found that testosterone levels fell far less in the fathers who did it more times per week. The idea of this influencing testosterone levels isn't new. The last study even showed if unmarried, childless men did it more often, they too tended to keep up higher levels. The short-term ability of sex to spike a man's levels is even more profound. Interestingly though, this elevation doesn't usually occur until the next morning. Since an increase in testosterone also signals the dopamine reward pathways, researchers think this boost the next day may serve as a reward for successful reproductive behavior. The spike appears to be even larger when the activity occurs in a situation where multiple males are competing, such as when it's with a new partner, which in one study increased levels the next morning between 60 and 330%. Tribulus is a key ingredient in many testosterone boosting blends, and a bottle of just Tribulus was actually my first experience with a testosterone booster. I was only 22 years old at the time, but within a few days of taking it, I immediately noticed a major change. I felt more intense motivation during my workouts and became more interested in girls. This positive experience was why it was one of my first YouTube videos. Enough anecdotes though, Tribulus is actually a source of some controversy, because although it's shown to reduce symptoms of ED and increase libido, studies show it doesn't directly increase testosterone levels unless they're already quite low. That hasn't stopped me from continuing to take it though. I look at the bigger picture because, looking at the data from before, it certainly promotes an activity that clearly does. So that's something I also recommend trying. Look specifically for the Bulgarian variety. You can usually find it in your local supplement store. That's where I bought it before I started taking the blend I linked below, which contains a full dose of it. Oh, and one more thing. Based on the research, this kind of activity, performed solo, doesn't result in a boost the next day, confirming it's the social cues that really matter here. While this information might give you new motivation in the bedroom, don't let it hurt your sleep. Remember how testosterone has a daily rhythm with a morning spike? Well, this spike also turns out to be sleep dependent. Reduced sleep seems to hit older men the hardest, with one study showing 4.5 hours of sleep corresponded with testosterone levels between just 200 and 300 the next day, while getting 7.5 hours of sleep showed levels ranging from 500 to 700. A study on young men found reducing sleep time for 5 nights from their typical average of 8.5 hours to just 4 hours and 45 minutes per night reduced their average testosterone well into the afternoon, from 515 to an average of 446. So it appears if we care about our levels, we should really be aiming for at least 8 hours of sleep. Finally, while the relationship between working out, muscle, testosterone, and fasting is going to get its own video, I'm going to quickly show how going to the gym can at least temporarily spike levels. Specifically, it's been found that workouts that stress large amounts of muscle over many sets, with moderate to high intensities and short rest intervals, tend to produce a big spike in testosterone levels, which can sometimes even exceed the size of the standard morning spike. So while this added spike would likely benefit you by significantly increasing testosterone exposure on the days you work out, evidence that working out could cause some kind of separate long-term increase in levels has been really inconclusive. This might be because the body is able to actually increase receptor density in the trained muscles specifically, meaning it can already precisely adjust a muscle's testosterone exposure without needing to resort to full body increases. Now that we've nearly reached the end, one last thing I wanted to include was the medical solution, called testosterone replacement therapy, where an endocrinologist will assess a man's levels and write a testosterone prescription to raise low levels. While I think it's a really good thing that this option exists for men who are suffering, I hope now that you've seen that many natural factors can influence levels, you might really consider trying those first. Usually, your endocrinologist will work with you to see if there are any lifestyle changes you might be able to make before jumping right into TRT. Because keep in mind that testosterone plays a role in our dopamine reward system, with small spikes working to reinforce behaviors related to success. A fixed replacement dosage, while it would resolve a lot of the negative symptoms, would theoretically make it harder for this situational reward system to function. Personally though, I do think I would still do it if nothing else was working for me. So as we wrap up now, I've put together a complete outline of all the T-maxing strategies I use, all based on what we've covered in the video. And there you have it. Unfortunately, there's so much more stuff I found researching that I really wanted to include in this video. Stuff on all the other hormones and how they all interact together, stuff on muscle and fasting, so I think I'll definitely be revisiting this topic in the future. And if you want to see that,
Consider subscribing, or who knows, you may never see me again. Also, feel free to follow me on my personal Instagram, shoot me a DM, like all my photos, it's up to you.
and as always, until next time, D-Man signing out.